Welcome to Code Guru Elite, your destination for mastering scalable backend systems.
Hey there, Code Champions. I'm Lakshman and welcome to Code Guru Elite, your hub for mastering Java, Spring Boot, and modern development. Today, we're diving into the heart of Java 8 and beyond, Lambdas, streams, and the magic of functional programming. Let's jump in.
Yeah, let's kick off with the Lambda feature that revived how we think about Java functions. So, what's a Lambdas? They are anonymous methods you can write inline like this. So, I'm showing you an example. Run R and brackets, and you can give the system out dot println, and there is only one method in this interface, that is an interface, functional interface mode. So what is a function interface? A function interface will contain uh, only one method. Okay, as it is an interface, and if it contains one method, then it is a function interface. Okay, so now function interfaces have been introduced in Java 8. Okay, so this is a run method. Okay, so what I will do is, like, I will this is part 1 of the tutorial. So what I will do is, like, I'm just for your example, for your reference, for easy understanding, I have created a small program, runnable R and system.out.println and r.run method. So what this will do is, like, it will run the system.out.println. So we'll get the hello world, hello from Lambda. So this is the first program that I have written. Okay, simple, right? Now let's go to the next program, which is a little bit more like it is also simple, but understanding it is very easy, so it should be easy for you. Okay, coming to the second part, what is a functional interface, which I have just now talked, is the backbone of the Lambdas. Okay, so lambdas don't float in space. They work with functional interfaces, each with one abstract method. Java 8 gives us several built-in gems. One is predicate, and we provide the T like that here. I'll show what I'm saying. So Java 8 possesses several built-in gems. Let me explain that one. Okay, so here I'll provide you some class file, some wait, if I get a text file, it is easy to explain. Plain text file. Okay, so here Java 8. Okay, now Java 8 uses several built-in gems, like predicate, uh, like a predicate. Okay, Java 8 gives us several built-in gems like predicate, and which returns boolean, functional, has takes input and returns output. I'm giving you in a simple format. Consumer, which takes input and gives no output. Supplier gives output and no input. Think of them as a reusable Lego bricks that power functional design patterns. Okay, now let's go to the functional, how we can create a functional program. Now the juicy part, streams API. Imagine processing data like a pipeline: filter, transform, and a collect. Here's a common pattern. So let's have one more example. So coming to lambda expressions, see, this is one more example, one good example. Let's go deep one by one into lambdas, and then we'll go to the streams API. First, let's complete as the lambda expressions. Then we'll go to the streams API. So now here you can see that list of string of names. You can see that array as list. Here we have created a names array list. Okay, in the normal way we use this for loop to iterate in this to this array list and then print the names. In the simpler we can do the same functionality in lambdas by only writing a single line of code. See, names dot for each name and system dot out dot println name. So array list has this for each of like a lambda expression. Okay, so let's go what is the like names dot for each. See, you can also write like that, system dot out dot println. This is one more version, easy to write. This is a method, this is called as a method reference. Okay, it's called as a method reference. Okay, now let me execute this one. See, this one is the first one. This is the first normal for loop which we write with this is the lambda expression with like this one, and the third one Lakshman Raju, this is the using the method reference. This is called as a method reference. Okay, uh, this is the class and this is the method name, like that. We can use this method reference. Okay, like this. Okay, so let's go to the what are the other lambda functions are there. Okay, so how do you write the basic syntax for any lambda is like this. Basic syntax is parameter and expression. Parameter and expression. Okay, now what we'll do is like a so here also you can see this example. It's a no argument parameter and expression. Okay, so like that. Okay, so so you can see this one. Okay, so I have told the predicate function consumer supply, right? In the similar fashion, real world example, I have teached you one example. Okay, then let's go with some examples with predicate function and consumer. And supply. Okay. So I'm giving an example. So okay, now let me give an example for the predicate. Okay, so let me comment this code. Okay, now let us go with predicate example. Okay, for this you need to import all the inputs. Java util dot predicate is the Java util dot function predicate, and we are passing the integer. If it is an even number, num percentage 2 is equal to 0. this is the lambda expression num, and this is the lambda like arrow symbol, and here we write the condition. Okay, then is even dot test. So in the predicate class we have one test function. See, test, and it will return only this boolean value. So what I've done is even dot test, and whatever the parameter that we want to send, we'll send it here. It is, if it is 4, it will check 4 modulo 2 is 0, then it will give even. Okay, output will be true. So this output would be a true. Yeah, see, true. Now if I put 5, the output should be false. Okay, so now I am just okay, wait, see, output is false. Now let's go to the function example. A function takes an input and returns a result. Okay, now let's go with this example of a function. Function is not there. Let me comment on this one. Function string integer string length is equal to str dot length import class java util dot function. Okay, system out dot println. Now I'm using the apply. Apply is the, in the function there is only one method, apply. It will give the t input and r as the output. Okay, string dot length. Okay, string dot length dot apply hello. It will check like if that string length is uh, uh, what is the string length. It will check and it will provide that length. See here, it is 5, the length is 5, it will print 5. Okay, so whatever the output that we want, we can check it this one. Okay, this is the function. Okay, now let's go with the consumer interface. Takes an input and performs an action without returning anything. It will not return anything. Okay, so let me go with that. Let's first remove all the things. Yeah, the code should be clean. Otherwise, it will the mess code will not give us any input output. Void accept, so it will also have, see, consumer has an accept, so it will only accept the things, it will not return anything. Okay, so here greet name system.out.println, and if we have print hello name greet.accept Lakshman, so it will return, it will print hello and that name hello Lakshman. It will provide any name that will be printed. Okay, So now you got the consumer. This supplier example. Let's go with the supplier example. Okay, supplier double random value is equal to math dot random. Okay, now let's import this class java util dot function, as I've told you already, system dot get. So supply has only one method, get. Okay, now okay, provides a result without taking any input. Does not take any input but provides a result. That is where we use this case. That is where we use it. Okay, now here math.random. Every time you click on, it will provide a random value. Okay, so if you want a one digit, then just multiply with 10. If you want two digit number, just multiply with 100. Like that you can do it. See, every time I click on that one, a new number will be generated. See, every time it is a new number. See, so this is the what is there in the lambdas. Let's go with the streams API. Okay, Java Streams, introduced in Java 8, is a game change for processing collections in a declarative and functional style. Instead of writing loops, you describe what you want to done with the data. Okay, a stream is a sequence of elements from a data source like a list, set, or array that supports aggregate operations such as filtering, mapping, and reducing. It does not store, it only processes the data. It's lazy. Operations are only executed when needed. It can be sequential or partial, parallel. Okay, a stream pipeline consists of source, collection, array, or input output channel. In intermediate ops, transformations like filter, map, there will be terminal operations. Final operations will be collect and for each. Okay, let's go with one example for the stream. Okay, let's consider our example that we have taken earlier. List of string names is equal to arrays dot as list of Lakshman, giving the taking the solutions. Names dot stream. So if you go with lambdas, then you can use for each. And if you go with the streams, then you need to use the filter with the streams. Okay, then what you can do, filter name which is name dot length greater than 5. 4, 5. Okay, so greater than 5, then dot map. I will explain you why I am putting this one. If you want to convert to any like uppercase, or if you want to do any operation on that string, you can just use the map. Okay, then you can use sorted, and then you can use the as I have showed you, these are the terminal operations like collect or for each. So now I want to just print this one. So I am using the last operation for each. to print this one. So these are all the intermediate operations. This is the source. Okay? This is the source, and these are all the intermediate operations, and this is the terminal or operation. Terminal operation. So it is the last operation is called terminal operation. All the other operations are called as intermediate operations. So this is intermediate operation 1, 2, and this is 3. So what I am doing, I am taking the name length greater than 5 and map. I am using the map to convert that to an uppercase and sort it and print line. So what it should be, greater than 5. So Lakshman and Rajesh, these only contain those information. If I put greater than 3, then all the 3 will be coming, all the things will be coming. So if I put like 3 and put as an enter, like now all the names should be popping out, because no, greater than or equal to, if I put this Raj is only 3 characters, so it has not come. That's the reason. Greater than or equal to, okay, now it has come. See all the things. So you can filter here. Based on filter, we'll get that one. Okay, this is one of the intermediate operations. So there are filter, map, sorted. So what does filter do? Filter will actually select elements based on a condition. See here it is a condition written, and based on that condition the selection will happen. And once that filter selection happens, it will create a new stream and it will provide that stream object to this. So map will transform each element. It will transform each element. It will go one by one element and it will transform each element. And sorted is to sort the array in the natural order. So there is one more word like a distinct and also flat map. Distinct actually removes duplicates. Flat map actually flattens the nested structure. So what happens if you provide any list or map, it will convert to a list operation. These are all the intermediate operations which I have discussed. The terminal operators are the collect. Okay, let me have in plain notebook, so plain text format, so it will be easy for you. So this is the intermediate operations. Intermediate operations are filter, map, sorted, distinct for checking the distinct objects, remove all the duplicates, flat map to get the uh, flat map is used to flatten nested structures. If you are having a map object, then you can get a flattened like a, you can get all it into a list. These are intermediate operations. There is one more key, then else, then or like that, and there is one terminal operation. Now the terminal operations. Terminal operations are for each.
చైత్ర కంప్యూటర్ ఏదో ఇచ్చిరు
Collect,
కంప్యూటర్
collect
పేపర్ ఉందన్న కంప్యూటర్
for each, reduce, count, 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 find first. Okay, collect is used to gather results into a collection, to get into one collection like a map or a list. For each is used to return action on each element, perform on each element. The for each operation is used. Reduce is to combine the elements into a single result, like if you want to sum up all the values, then you can use a reduce and you can give the what needs to be done. And count is used to count the elements. and find first is used to get the first matching element. Okay, let's go with one example for this to get the list. This is where like uh, the filtered list I am just getting it. So this is one way of see. Okay, okay, I got it. This names Lakshman, this one filter. I just names dot stream. After that, I'm doing filter operation starting with L. Okay, L. Okay, then I want to create one uh, list. Okay, just I'll use this other names. Okay, so now now names is one array list containing all the elements, and here filtered list will stream first this one. It will stream this one. It will use the filter operation, condition operation, and then it will collect it, and collectors dot to list collect dot collect, and in that one collectors dot to list it will print all the filtered list. Now let's run this one and check. See, where is this println? There is no println statement. So we can use the we can use a println. Now if I print, you can see the Lakshman this one. Okay, I'm okay. So now this is the part one of this one. Part one of lambdas and streams function interfaces. Let's go in depth in the second